Hi, Richard again from Past That Science. So let's get into a delta question this time. A delta connected three-phase system has a line voltage of 400 volts and a phase current of 20 amps. What would be the phase voltage and determine the line current? A lot of these things are quite a visual learner myself, so I like to see visualizations of stuff. So a delta connected system, this is what delta looks like, and I've put the labels in there. This is where you'd measure line voltage between the two line conductors, and in the line there would be the line current, and then across the load is where you'd get your phase voltage, and through the load there is where you'll get your phase current. Okay, so let's have a look at the question then. So the first part of the question is what will be the phase voltage? So what we're looking at is what is this voltage going to be here? I think this is probably the easier of the two questions. Think about things this way. So if I took a voltmeter and I measured it across the lines, what would I get? Well, with the same as the voltage here, I would get 400 volts. So would it make any difference if I was to take that voltmeter away and place it there instead? What am I going to get? Yes, indeed, I'm going to get 400 volts. And if I move the voltmeter to here, what am I going to get? Yes, 400 volts. And what if I was to put it there? 400 volts. And so what if I was to place it across the load there, bearing in mind that this wire is connected directly to that second line conductor. This wire here is connected to that first line conductor. So therefore it should measure the same voltage. It will measure the same voltage. So therefore your answer to this question is quite simply 400 volts. Delta, the voltages don't change in delta. Okay, the voltages stay the same. On to the next part. On to the second part of the question then. The question is determine the line current. Well, this is where the line current flows down this conductor here, and what you may notice is then that the current will then split, it will divide into the two paths here that I'm indicating with the little laser pen. So if I have 20 amps running down here, and assuming I've got a current running down here, that will lead you to think then that the line current flowing along here must be higher than 20 amps, because some of it is flowing down here, the rest of it is flowing down here. We don't know what that is at the moment. We're going to assume it's 20 amps the same, but anyway. So it's formula based, of course, as all these things are. The formula is that your line current IL is the phase current IP multiplied by the square root of 3. That square root of 3 is always that relationship between phase and line values in three-phase systems. The other thing you may need to think about is, of course, this is your line current, and as we said, that the line current value is going to be higher than the phase current. And where there is a difference, okay, the line values are always the highest. So in a star connected system, if you're looking at line voltage and phase voltage, it's the line voltage that would be the highest. So we're looking at a number that's going to be greater than 20. So let's put the values in. So line current IL is the phase current, which is 20 times by the square root of 3. When you run that into a calculator, that comes out as 34.64 amps. A quick sanity check. Does that make sense? 34.64, we're looking for a number greater than 20. It's the right ballpark. Okay, question done, finished. Thanks for watching. Now go past that science.